I want to start doing something a little bit different as we proceed further into the course, and the code gets naturally more complex. In some instances, it takes me quite a while to set up the code before I have a starting basis for the new content I want to teach. Moving forward, I'll try to do this setup work in a separate video when it makes sense to do so. I'll introduce this code as an optional challenge for those who really like the independent work. If you feel like you need extra time with some of the basics, definitely take the challenge and follow along with me in this video as I set up my own version of the code. If you feel like you don't need this review and aren't interested in the challenge, then feel free to skip this video. I'll review this code in much briefer detail at the start of the video where I introduce it, and the source will be available as a download for you in the resources section of that video. I'll also try to mention any specifics in the code in this video that might be a bit new, and that will be covered shortly, or if it is a variant of something we've used previously. For example, in the code I'll be reviewing in this video, my code will include the use of a record, a nested enum on that record, and the use of list functions you've already been exposed to. I'll be using ASCII codes to display the suits of the cards. In this video, I want to set up a card class which will be used to create a deck of playing cards. I'll be using these cards and decks of cards to demonstrate many of the methods on java.util.collections. The card will have 3 fields: a suit, meaning club, diamond, heart, or spade. This will be an enum, a face field, which will be a string containing either the number of the card or the face value of the card, jack, queen, king, or ace. A rank, an integer. The card should override the toString method and print the card with the face value, abbreviated if a face card, the ASCII character of the suit, and the rank in parentheses. I've included the ASCII characters that will print out each suit as a printable character. The output shown here shows all the cards in a standard deck of playing cards sorted by suit and rank. The card should have the following public static methods to assist anyone using this class. GetNumericCard, which should return an instance of a card based on the suit and number passed to it. GetFaceCard, which should return an instance of a card based on the suit and abbreviation J, Q, K, A passed to it. GetStandardDeck, which should return a list of cards you'd find in a standard deck. See the previous slide for a full set of cards. PrintDeck, which should take a description, a list of card, and a row count. This method will print the cards out in the number of rows passed. Finally, the card should have an overloaded PrintDeck method that will print current deck as the description and use 4 as the number of rows to be printed. If you want to take this as a challenge, pause the video here and go ahead and try that out on your own. When you're ready, come back and I'll walk you through this setup if you want the extra walkthrough. If you feel like you don't want to go through this setup or need the additional walkthrough, don't worry. I'll introduce it with a brief overview in the next video, and it will be in the resources section of that video as well as this one. Pause the video now. Okay, so welcome back. If you've come back to walk through this setup with me, did you try this out as an independent challenge for yourself? How'd you do? Hopefully this was a little fun for you, if you did decide to try it on your own. This slide shows my own plan, the class diagram I'll be coding towards. Study this for a moment. I'm going to create a card class. In my case, I'm just going to make it a record, because once a card is created, there's no sense in allowing anyone to change it. Using a record gives me built-in immutability if all my attributes are simple data types like primitives and strings. Maybe you decided to create a deck class to contain your cards, and that's a good idea too. For the examples ahead, I'm just going to use list as my deck container. I've created a project called Collections Methods, which I'll be using in upcoming videos. First, I'll create a new record in the dev LPA package and call that card. I'll add my fields in the parentheses there. First, a field with a type of suit. That type is going to be an enum I'll create shortly, and that field will be named suit in lowercase. I'll follow that with a string field called face and an int named rank. I'm going to insert my enum suit as a nested type in this record. I'll make it public because other classes not in my package might use it later. I'm designing it for that possibility. It'll have 4 constants, each representing a suit, so club, diamond, heart, and spade. For the standard deck, there's no real difference in ranking for these suits, so my ordinal value in this enum isn't really important. It doesn't matter how I list my constants in this enum, so I'm just choosing alphabetical order. I've added a semicolon after the last constant because I'm going to include an additional method on this enum. The public method will be called getImage. Its purpose is to return the ASCII character to print for each suit, which I gave you on the slide at the start of this challenge. I'm just going to set up a char array of those values in the same order as my constants, then index that array by the ordinal value. That completes the enum. For the card record itself, I'll first override the toString method. I'll delete the default implementation. I'll set up a local variable called index, which in all cases will be 1, unless my card is a 10, which is the only case where I want 2 digits to be retrieved. I'll retrieve either the first number or letter from the face field of the card, or just 10 if it's 10. And I'll return a formatted string, which I also showed on the slide, which is the number or face card abbreviation, the suit character which I can get from the getImage method I created, and then the rank of the card. I want a bunch of public static helper methods on this class to help anyone building a deck or printing out a list of cards. I'll start with the method to return a standard numeric card, so it'll be public static, and the return type is card. I'm calling it getNumericCard and passing it a specific suit and a card number, so this will be a number between 2 and 10 for a standard deck. I want to make sure the card number passed is really a number between 2 and 10. If it is, I'll return a new card instance with the suit passed, the card number as a string, and a generated rank. I want my lowest card to have a rank of 0, and since my lowest card is a 2, I'll subtract 2 here. Finally, if this method was called with some other number, I'll print there was a problem, and return null in that case. The next method, getFaceCard, is going to be very similar, but instead of taking a card number, it will take a char, the abbreviation for the face card, so J for Jack, Q for Queen, K for King, and A for Ace. I'll validate that the character passed is one of those 4 by calling the index of method on a string that contains only those 4 characters. This card isn't checking for the proper case, and you could add that if you wanted your own code to be more robust. In general, the mechanism for creating a card will be in the context of creating a deck, so I'm not going to be too worried about bad data getting passed in here. If the index is greater than -1, then it's one of the 4 valid letters. In that case, I'll return a new card instance with the suit specified, the abbreviation passed as a string, and again a generated ranking, such that a Jack gets the rank of 9 and an Ace gets the highest rank of 12. If the code falls through to this point, an invalid character was passed, so return null. These 2 methods can be called by our client, but in most normal circumstances, they'll be called by the next method, which returns an array list of cards, the standard deck of 52 cards, every card unique by suit and face card value. Not all decks are standard. If any of you have played Pinochle, you'll know there are other variations. This method again will be public and static and will return a list. I'm going to specifically make a list of cards, and the name will be getStandardDeck with no parameters. I'll first set up a local variable, again list of card called deck, and I'm assigning a new array list with a capacity of 52, since I know this is the size of my deck. At the end of this method, I'll return this deck, so I'll add that statement here for now. What I need to do between those 2 statements is add the 52 cards. I'll loop through my enum values, my suits, using the values method on enum, and a for loop. For each suit, I'm going to create a set of numeric cards, then a set of face cards. My first nested loop will loop from 2 to 10. I'll add the card I get back from calling the getNumericCard method, passing it the current suit and the loop variable I. This nested loop will loop through the 4 characters that represent my face cards, J, Q, K, and A. And add the card calling getFaceCard to obtain an instance. This method will give me a deck of 52 cards in 4 suits. First the cards 2 through 10 ranked from 0 to 8, then the face cards, Jack through Ace ranked from 9 to 13. I want to include a couple of overloaded printDeck methods next. These are public static void and take a list with a type argument of card. The first one also takes a description and the number of rows desired. I'll always print a separator line of dashes to help see different outputs. If the description passed isn't null, I'll print it out. I want a local variable, cards in row, which is the number of cards to be printed on any one row, which is the deck size divided by rows. If I passed 4 as rows and my deck was a standard one, I'd get 13 cards in 4 rows this way. I loop from 0 to 1 less than the rows. The starting index will be I times the cards in the row. So for the first iteration, this will be 0. For the second in a standard deck, it'll be 13, then 26 and so on. The ending index is just the starting index plus the cards in the row. Next I want to use the start and end index to get a sublist of my deck. Then I chain the for each method to the sublist, printing each card on the same line, separated by a space. After each row of cards, I want a line break. The overloaded version of this method will only have a list of card, and we'll call this method with some defaults. I will just call the overloaded version with current deck as the header and 4 rows. I'll move this overloaded version of the print deck method above the other one by cutting and pasting it. So that's my setup. I'll test that this code works in the main class's main method by calling the getStandardDeck method on the card class, assigning it to a variable, and then calling printDeck on the card class. It's time to test what I've created. You can see why I wanted to print my deck by rows. It's easier to see all the cards this way, and when I create a standard deck, they're ordered by suit and rank, as you can see. Okay, so that's the setup. This code will be used in the next few videos, where I am going to cover a new class I haven't yet talked about, and that's java.util.collections, so I'll see you in the next video.